What we're going to look at here is a thing called the product rule. Our interest is in multiplying exponentials, and we need to have a way of working with the powers on them. So we're going to develop the product rule and use it. I want to start with an example, and it will be a numerical example, one that's fairly easy to work out. We'll take 2 to the 3rd power, and we'll multiply it by 2 to the 5th power. And let's start by writing it out longhand. 2 to the 3rd means 2 is a repeated factor, and it appears 3 times. So we have 2 times 2 times 2. And then we're going to multiply that by 2 to the 5th, which, of course, is going to have 2 appearing 5 times. 1, 2, 3, 4, 5. Rather than writing out the numerical answer right away, what I want to do is write this in a shorthand. If we were to look at this piece and use the same kind of shorthand for an exponential as we did over here, what we notice is that our base is still 2, but the 2 is repeated still, and the total number of times it appears is 8. So if we were to write the answer in an exponential form, our power would be 8. This is 2 to the 8th power. And what I'm interested in here is seeing what's going on with those powers. You might notice that 3 plus 5 very handily gets us that power 8. We're going to jump from this example and generalize with the product rule. And this is something that I like to call flashcard fodder. You will need to have this committed to memory. That can happen by practice or by using flashcards, whatever method works for you. You're going to get to practice anyway. If we have some base a and it's raised to the power m, and we multiply it by another number, and that number has the same base, a, but it's raised to a different power, as with our 2 to the 3rd and 2 to the 5th, we can find our answer simply by adding the exponents. So we would say we have a to the m plus n power. And that would be a very important rule to memorize. In words, when you multiply, you are going to add the exponents. It is critically important that you have the same bases, and you leave the base alone. Now, of course, we're going to work some examples, and we're going to start with a numerical example much like the one we opened with. Let's take 3 to the 2nd power and multiply it by 3 raised to the 3rd power. What we have is 2 exponentials. They have the same base, and that base is 3. So our answer, writing it again in an exponential form, is going to have 3 for a base. The power on our example will be the sum of the 2 powers we started with. So we'll take the 2 and add it to 3 using our product rule. And we'll be left with 3 to the 5th power. Now we're going to do another example, and this one is much more interesting than the last example. What we're going to focus on is the exponentials, which happen to have the variable x, and how we're going to get those together. I'd like to spend a little bit of time with this negative x. Remember that negative x means negative 1 times x, and that when a variable stands alone, it has the power 1. what we have then is this 3x to the fifth times 2x to the third times a negative x. And we're going to group together all of these numerical coefficients. So we'll have a 3 times a 2 times a negative 1. And then we're going to apply our product rule to the variables, or variable. We have x, that's our base, and it is going to have a power that's the sum of the 3 powers we have in our example. So we're going to take the 5 and add it to the 3 and the 1. And it's this piece here where we have applied our product rule. What we have then is 3 times 2 times negative 1, which is just a negative 6. And x is to the power 8 plus 1, which is 9. This is a much simpler way of writing that product that we started with. And that is our final answer. The important point, again, of this segment is that when you are multiplying exponentials, you are going to add the powers. And that is our product rule. Which was a raised to the power m times a raised to the power n equals a raised to the power m plus n. And again, the bases must be the same, and we don't mess with the base. We leave it alone, and we just add the powers. And that is the end of this segment.